I'm sure I'm speaking for all of you that this morning's sessions were really inspiring. I learned a lot. We're going to have a similar theme throughout the afternoon of a mix between how you do well and do good in the space of precision health, and that's very much the theme for our afternoon keynote. So it's really my honor to introduce Patricia Geli. Patricia's been a driving force behind addressing some of the most complicated and challenging issues facing our planet, from outbreaks of infectious diseases like Ebola to the impact of mining on health outcomes and economies. We're going to hear from her on how we can leverage AI to both do well and do good, with a specific focus on equity, which is something that we need to be carrying with us into all of the solutions that we develop and a lot of what we heard about this morning. After the talk, Gene Tunick and I will have a little bit to say about some of the work that's happening at Northeastern, but please join me in welcoming Patricia for the afternoon keynote.
Hi everyone, good afternoon. How was the morning? I must say I am really honored and privileged to be here today, and I want to thank the Institute, thank Osama Fayyad. I'm just so honored to be here after all those amazing speakers this morning, and this institute really rocks. You really know how to bring amazing people together and how to really set the stage for how to do applied AI. It's hard to speak after so many brilliant speakers this morning, and especially Professor Larry Brilliant, who also inspired my journey when I was a PhD student over 20 years ago. I've had quite a non-linear path in life. I started as a math PhD and worked with smallpox eradication planning, and got a bit obsessed with diseases and continued to do studies in that field. Today I promise to share my perspectives as a VC. But I wanted to start by sharing one of my, putting on one of my other hats, which is the economist hat. I spent 12 years or so at the World Bank as economist and investment project leader. How do I change the, here. No? Okay, there you go. Okay, so in economics, there is a concept called the cost disease. So I don't mean the cost of disease, but the cost disease. This was a term that was coined by Professor William Baumol, who was also a Nobel laureate. So it simply describes why cost increases in healthcare are skyrocketing compared to other sectors. So as you will see on the slide, on the top there is actually the cost of education. That's another sector that suffers from the cost disease. And the next subsequent lines on top there are the healthcare sectors. So in contrast to other sectors, manufacturing, consumer goods, etc., scale does not lower cost. And as other sectors are becoming more productive and can raise wages, and they can raise wages, healthcare sector needs to compete, and that drives up the costs. So that obviously creates a challenge for governments and for policymakers who are trying to reduce spending. I spent many years doing Article 4 missions with the IMF and working with governments and ministers of finance. We're very eager to slash the healthcare budget because it's rising as a proportion compared to the rest. So it's a big deal, and especially you might have heard during election times. So why is this? Well, wages is not the only factor in this case contributing to the unsustainable growth of healthcare spending. As we can see, if we compare the costs of healthcare and life expectancy compared to other developed countries, we're not really doing very well here in the US. It is more expensive, and we have worse outcomes compared to all the other developed countries. So there are many reasons for this. One is the fragmented billing and reimbursement systems. These are significant drivers. There's also a very high rate of medical errors, and this is really a symptom of this broken system that we have. If you look at recent numbers, 800,000 Americans die or are seriously injured because of medical errors. And Johns Hopkins estimated that every one of us will suffer from one of these medical errors throughout our lifetime. So, what does the future look like? We're trained to think, at least as an economist wearing that hat, we're trained to think about a world of resource constraints. For instance, one of the countries that I worked on, South Sudan, the budget per person per year for healthcare was $2 per person per year. Once that funding reached the local governments from the central governments, what was left was 50 cents per person per year. But again, I don't think that resource constraints is the right way to think of the world right now, because the way we know it, has already changed. And if you think of it, AI today, I'm sure everyone is very familiar with ChatGPT right now. But did you know that ChatGPT, if you look at the IQ, ranges from 110 to 155, roughly. Einstein's IQ, my favorite person, had an IQ of 162. So just think of it. That's how far we have come in a very short time since ChatGPT was popularized. And some estimate that AI will be tenfold, the IQ of AI will be tenfold in a year from now. So the world is not changing, it has already changed. Protein discovery, we saw the recent Nobel Prize for that, is just one of the breakthroughs to come, that we have seen, more to come. I actually believe that we had more than one Nobel Prize awarded for AI discoveries. But I actually think that very soon an AI will receive the Nobel Prize. That's my projection. So back to the future. Corporations, governments, financial houses all spend tons of money on prediction based on past data. But when it comes to predicting the future, I think that it is actually better discovered by iterative, venture-backed experiments. And that's where I find myself right now. And that's where I get really excited about the future. Another one to quote Steve Jobs today. One of my favorite quotes. So, as a VC, we try to back the crazy ones. Raise your hands if you think you're one of the crazy ones. I hope to see many hands. So, as he said, the crazy ones are the people who are crazy enough to think that they can change the world are the ones who do, right? And in the VC world, we often back people and ideas before they even have cash flows to analyze. So we sort of find ourselves in that middle layer between the two other sort of market forces, really the market force and the corporations, which is very top-down driven. But what we try to find are really the moonshot ideas that will create nonlinear progress. And today I wanted to share a few of those bold ideas that we are thinking about, and also share a little bit of my thoughts about how those bold ideas are not just for the rich world when it comes to precision health, but actually is applicable to resource-constrained environments as well, such as South Sudan, which I mentioned. And I will try to leave enough of time to hear your thoughts. So first, let's look at what is the number one killer in the world. Chronic vascular disease is responsible for a third of all the deaths in the world. It adds over 1.1 trillion in the world, cost in the world, in the US. And 85% of those outcomes, heart attacks, death, stroke, amputation, are actually preventable with early diagnosis and timely care. So why don't we get it right? So one of the biggest challenges here is misdiagnosis and underreporting. There's a shortage of radiologists, and they are burnt out. We have an amazing team, venture team working with us, both our radiologists, the co-founders, and looking at the data and what a normal day looks like. I know there were a couple of radiologists talking earlier as well, so you know this area much better than I. But if you look at the number of images that they have to analyze, they have to look at 11 images on average per second. I think all of you would agree that that's a really hard task to do for anything, regardless of how many hours of training and practice you have. If you look at the outcomes today, most people only discover chronic vascular or cardiovascular disease by having a heart attack, rather than 20 years earlier when the symptoms are actually visible. So, as mentioned, we're working with a startup, Guide AI Health, which is using PVD as markers to actually catch these early signs. We are making great progress. I'm very excited about rolling this out. Early stages still, as I mentioned, we're backing very early stage ideas. But the good news is AI doesn't suffer from burnout. It can process thousands of data points, identify early signs of disease much faster and more accurately than humans. So this is one of the ideas that we're very bullish about. And it's also one idea that can help close a health equity gap, because there are a lot of disparities, especially in cardiovascular disease, both gender and race and the location where you're based. The other thing that we're looking at, I know we had amazing talks and conversations this morning regarding drug discovery. Melissa Landon, among others, gave an excellent talk, so I won't go into many details here, except to say that traditional drug development, the way it looks like right now, takes a long time, it's very slow, it's very expensive, and it's very inefficient. 13 years, 2.3 billion on average, 90% failure. So one of the areas that we're backing here is we're working with a startup called Deep Kinetics that has developed digital twins to standardize tissue-based data. So what they can do is to simulate drug effects faster with more accuracy without animal testing. So it's leveraging both machine learning and generative AI. This is an area I'm personally also very excited about because I actually started my journey in AI in 2005, roughly 20 years ago, trying to model pharmacokinetics and pharmacodynamics for antimicrobial resistance, which you will hear more about. But it's very hard, it's very slow, and that's what got me into AI, actually. But we have come a long way over the past 20 years. So AI cuts the development time to 7 to 8 years here, reduces cost, and improves success rates. As mentioned, antibiotic resistance is something that has kept me sleepless for probably 20 years now. It is a silent pandemic, and since penicillin was discovered in 1928, I'm sure you all have had at least one cure of penicillin or antibiotic at some point. These drugs have become increasingly resistant to bacteria. And there was a recent UN meeting, the UNGA meeting, which met in September and set goals to reduce death by 10%. The estimate that they gave was that AMR, antimicrobial resistance, would cost $412 billion annually, and 40 million deaths are estimated over the next 25 years. So when they set a goal of reducing death by 10%, do you think that's very ambitious? I think 40 million deaths sounds very scary, and we ought to do something more than just a stepwise change. I think we need nonlinear thinking, and this is one of the areas where I think these AI digital twins can come in to support developing new drugs and to support also simulating, understanding better what drug dose combinations that actually minimizes the risk for antibiotic resistance developing and then subsequently spreading between people as well. Another thing that has kept me sleepless at night is malaria. Malaria is killing still 600,000 people annually, despite us now having vaccines, which are less than 50% effective. There is a drug that was developed decades ago, tafenoquine. It is a potential game changer if we can make it safe. But there's a deficiency, a protein deficiency called G6PD, which makes it potentially lethal to 10% of the population. So this is one of these, and the reason why this drug is unique is because you only need to take one pill. So it's really suitable for compliance and for using it for mass eradication, only if we can make it safe though. So another sort of moonshot idea to use these digital twins to figure out the right combination to be able to deliver it for mass eradication safely. If you want to work on any of these things, I'm going to be all ears afterwards. The other thing, let me just jump into this picture. Most people don't think that this is in Ethiopia, but it's actually in Addis Ababa. It's the headquarters of the Africa CDC. Which was established as a new public health order in 2014-2015 when the Ebola crisis was raging. African leaders said, 55 countries, that enough is enough. We can no longer rely on foreign governments outside Africa for our public health safety. At the time, after I was based in Sierra Leone during the Ebola crisis, and after this crisis, I joined the people who said enough is enough, and I led efforts for 2 years lobbying for $250 million financing to help establishing the Africa CDC, which was very timely approved just before the pandemic hit. During the pandemic, it became a bright star. When other countries were acting in isolation, they were acting in solidarity. And how do they do this with resource constraints? Well, they actually structured this as the institution as a sharing economy, basically, for public health assets. So not every single country needs to have every sort of genome sequencing, the latest cutting edge machines, but they can share it, and they can share the knowledge as well. And that's how they were able to scale up from one country testing for COVID to 55 in just a couple of months. The reason I'm bringing this up is because it serves as a source of inspiration. A source of inspiration for thinking big about what we want the future to look like. Not where we are right now and having those incremental changes, but actually to paint that picture of what the future could look like and then model what we need to do to get there. The other thing that they did with 1.2 billion people and 55 member states, they were still importing 99% of their vaccines, and very often getting an 80% markup. So today there are 5 centers, vaccine manufacturing centers, that are actually now supporting the supplies of the continent, and they expect that by 2040, they will manufacture 60% of all their needs. So that's quite a moonshot thinking. As part of this networking, the networks that they did to be able to maximize all the public health assets that they had, they did the same with genomic surveillance. So one of their centers of excellence, led by Christian Happy in Nigeria, managed to sequence the first genome within 48 hours during the pandemic. This is a key area for a continent that will represent 25% of the global population by 2050. So getting that diversity of data and representation of local data is key as well. And I know that time is up, so I just want to end on one thing really quickly when we talk about health equity. So 19 years is the difference between South Sudan and US in terms of the health gap. But we have an even bigger gap if you look across the river from Cambridge and this side. Roxburgh to Back Bay is 23 years, so something to reflect on when we work with developing our AIs for healthcare. So, yeah, I think my time is over, but I want to leave you on that. So thank you very much.
We do have time for a few questions. There's a microphone in the middle.
So I have a quick question. So I did a project on antibiotic stewardship. So I majorly worked on carbapenems. So I found that only 77% of the guidelines are followed by institutions for the antibiotic stewardship program. So I feel like there is a lot more when it comes to antibiotics. And I agree that there is a lot more to research on antibiotic resistance. So, like, how do you want to approach when it comes to antibiotic resistance?
That's a very good question. I think that it has to be a multi-pronged approach. I think we desperately need more antibiotic development. The incentives for the pharmaceutical companies today are close to none, because infectious diseases is something that you suffer from for a very short time. And so you don't get this lifelong dependency like cardiovascular disease, drugs for depression, or Ozempic now, I guess. And so without those monetary incentives, there's just no one developing those drugs. So that's one of the things, and that's where AI can actually have a huge impact in terms of finding new drugs, together with technologies like CRISPR. Now, I think the other thing that I mentioned is to really utilize some of these sort of digital twins and other AI-driven technologies to optimize what the drug response will look like, the PK/PD dynamics within the body. So very often, same thing with that any sort of drug dose recommendations are usually based on sort of toxic levels, but not with a view of minimizing resistance. And because it very quickly becomes complex and difficult, and that is where AI is actually, it's useful to have all these Einsteins that we can just tap into by plugging into the wall.
Thank you so much.
Hi, thank you. Dr. Marie Nahal again. As somebody who's been sort of on the social sort of mission side, as well as now as a VC, a lot of times there's a question, should you be a nonprofit or a for-profit? And if you've been watching the news, like for instance, 23andMe seems to be in trouble, and there's a lot of questions what's going to happen to their data if they get purchased. So if you go the VC route, for-profit, your goal is to exit. And then you may lose control of the data that you gathered. So given sort of from an ethical perspective of thinking about, how do you grow fast and have market share so you're relevant versus maintain control? And am I being too kind of black and white about this? And is there a better way to think about this?
It's a very good question. Do you have any response to it?
I mean, I think about ways.
I'm sure you have been a VC longer than I, but
I'm not a VC. Yeah, I'm pitching to you actually. So I'm a founder, but I mean, what I think about is there a way to have decentralized data and anonymized and not so you're kind of almost like the federated model of having the insights rather than the data. Those are things I'm struggling with.
I think that's a super important question for many reasons, because first of all, startups have and will always be the engine of the economy. So we need startups. And if we are to get more startups in this space, they need to be able to build a moat around their companies. And how do they build a moat around their companies? Well, it usually is the data. For an AI company, it would be the data. So what I am recommending generally is to be cautious when we create legislation around AI. There's a lot of movements around going very quickly to data minimization. And I think it's important for some variables, and I think data privacy is also very important to do that, but it has to be case specific. It can't be a blanket statement because it does harm the sort of startup community overall and progress in many sectors that can benefit humanity overall. So case specificity, I think, is very important in this case.
Thank you.
We have time for 2 more questions if we're quick.
Thank you for sharing, Gary Kenyon. I'm a drug developer and former board member of the Global Alliance for Prudent Use of Antibiotics. Thank you for your flagging. Antibiotic resistance is certainly largely underestimated. And an additional comment to your contribution for finding new drugs is certainly using AI for preventing misuse
Yeah.
of antibiotics, which we had largely demonstrated that was a major factor in resistance developing. Thank you.
Absolutely. Yeah, there's a lot of misuse. Yeah.
Thank you. Hello. Yeah, I'd like to thank you for being a speaker here at Northeastern University's State of AI for Precision Health. You're giving a very lot of information, doing 20 years here, 30 years here, appearing as a college student, and you were back there helping Mr. Brilliant fight smallpox. I don't know. Are you an AI humanoid? I mean, no, really. I'm a founder, and trying to find out if the need to be able to assist to formulate a digital health twin from smart homes. So what I might do is I have patent products, patented smart bathroom fixtures, and smart healthy toilet, smart mirror, and certain other great features that help to remotely create a digital health twin of the patient. So I was trying to figure out if there is a way that will give, as a startup, we'll be able to give investors a credibility of to be able to have a gold standard testings and all that to be able to have the oversight that's needed for all these places that don't have the facilities and stuff like that because of my startup basically turns your bathroom into your doctor's virtual office. We create your digital health twin and all that. The smart toilet seat, for example, it takes your temperature, your weight, your BMI, and your blood pressure, and other features. That's going to go supplement the smart watch, the Fitbit, and all these other wearables to help to be able to assist you with your digital health twin. So I'm hoping that something like that would interest. You say you invest in startups, so I'm trying to put my startup out there.
I'm happy to. I'm happy to continue talking and would
Great.
like to hear more.
Thank
yeah,
you.
Thank you for that comment.
I appreciate it.
One final question.
Thanks, Sam. Thank you, Patricia. My name is Rupal Patel, and I had a question for you about the ideas or discoveries back in Africa. How many of those, or can you think of some that are so important that we should be bringing them back here in the U.S., especially when you talk about that gap between Boston, between Back Bay and Roxbury? What are things that we're not doing here that other places, especially Africa, because they sort of skipped they went all the way to mobile so quickly. What has been the advantage of going to mobile so quickly in healthcare that you think could be great for us to be tackling here? Thank you.
That's a wonderful question. I think, first of all, bring back some of that solidarity that we saw on the African continent with 55 member states working together, meeting on a weekly basis throughout the entire pandemic. I think that's greatly needed in society today. I also think that very often it's a benefit to not have a legacy system. So now I mentioned a lot of these sort of shiny ideas, but actually many of the most important, solutions from AI is in the more boring processes, cleaning up some of those admin processes and consolidate the system in a better way. So I don't know if that answers your question, but I think those are the most important things, I would say.